So I'm here with Xavier Rosaire at Thales Alenia Space in Cannes, France. And Xavier is an aerospace engineer who is the product line manager for science exploration and in-orbit servicing. That's a mouthful, but we've been talking about space-based solar power. Xavier, can you tell us what space-based solar power entails and what you, along with ESA and your consortium partners, are actually working on with this?
Yes, we've got space-based solar power consists in capturing the energy from the sun and transmitting it to Earth. We are actually studying two types of concepts. One being just having reflectors, beaming the sunlight back to Earth on a solar array field on ground. And the other one consists in producing, like satellites do, energy from solar rays and sending it to Earth through radio frequency beams.
And this is not a new idea. This is actually an idea, the original patent dates back to the 1960s, if I'm not incorrect.
No, that's right. The idea has been around for a long time, and what we are doing now in the frame of an ESA study is really assessing the technological interests and potential of this technology, but also what are the gaps. One of the difficulties, of course, is to make it economically viable, but also to tackle societal impact, environmental impact, and cover the complete life cycle.
And what's driving this all of a sudden? I mean, why now?
Now, this driving is that we see that we've got a big challenge to reduce our greenhouse gas effect generation, which for a large extent is produced by different use of fossil energy. And of course, the space-based power appears to be something interesting from this point of view. The challenge is to compare it with other sources of energy to see the value and if it is a sustainable and economic system. So that's the first step of this study, and also to assess the technological breakthrough which are needed to make it a competitive solution.
And so is the cost of launching a constellation of satellites getting to be low enough that this is feasible economically?
Yeah, that's the point. Likely the space access costs is one of a topic which can be an enabler, and likely it will be something moving in the next generation of launcher to bring more mass on orbit for a lower price per kilogram, contributing to affordability of this type of system.
And so what about people who simply say, why don't we go nuclear, or why don't we do more Earth-based solar? Why bother doing this type of study from using, and let's be clear for those who didn't hear it, we're talking about collecting solar photons in Earth orbit and beaming them back to Earth, either by reflecting the photons back to Earth or converting the photons into microwave energy and beaming that back to Earth. Is that correct?
Yes, that's correct. We could also consider, that's also one of the points we are working on, using the energy also on orbit by putting up activities like space-based center. That's also a topic we're working on, but that's the basic idea is indeed to see if we can produce energy on ground using the solar photon.
And so, but again, why not simply go with existing renewable energy sources rather than looking to space?
What we are looking with the space energy is to see if we've got something which can be more permanent and continuous production. Lots of sources of energy are renewable energy, like solar power are depending for the night and day on the cloud side, whereas satellites in geostationary orbit, for instance, can get almost all the time the sunlight and could support a continuous production. And which is one of the issues on Earth is to the ability to regulate the energy production or to store it, which are difficult topics.
And even if this is successful, your study is going to be finished by the end of 2024. You'll take it to ESA in 2025. If the ministers at the council level, if the ministerial council of ESA decides to proceed with funding, we're talking about long-term development, possibly 10 to 15 years, correct?
Yes, that's correct, because that would be innovative technologies, needed some new developments, an in-orbit demonstration would be needed. So that would likely take a first 7 to 10 years to get to an orbit demonstration. And then we'll have to make the step for demonstrating the system and the principal technologies to then make a larger infrastructure. And this would take an additional likely 7 to 10 years. So it's a long-term development and perspectives.
But fascinatingly, it may see first use on the moon itself as a source of power.
Yes, the moon in a way could be as bigger issue than on Earth. Bringing energy on the ground on landers is expensive, and the lunar nights are very long because of in the order of 2 weeks. So reflecting energy from space on the lunar surface could be interesting for the exploration program of the moon, where the next step now with the Artemis program is to place sustainable infrastructure with long lifetime on the moon and to operate both during day and nights. And typically that's where we can fly lower around the moon. We don't have atmosphere perturbating the reception of energy. So this could be a first application, and the business model will be better because bringing energy on the lunar surface is more expensive, of course, than the one produced on the ground. So that could be a kind of intermediate step for this type of technology.
Well, good luck on your study. Thank you so much for your time here. And on a beautiful sunny day, the sun is such a wonderful source of energy, and we can see why you're doing the study. Thanks so much, Xavier.
Thank you.